Hey there. I'm showing you how to grade and the correct answers to 2010 AP Calculus pre-response question. I believe this is 2010 number 4. So here we go. I gotta keep this hopefully under 5 or 10 minutes so y'all can quickly grade your homework. All right. So let's take problem A. Um, I'm sure you've already read the situation here. So problem A, at what times in the interval 0 to 18, if any, does the squirrel change direction? Give a reason for your answer. Well, the solution for A is at time t equals 9 and t equals 15. In an AP setting, on the AP exam, these would be worth a point each, or we'll count them for a point each, but I think they'd probably either be both worth a point together or a point each. So there you go. Now next it says give a reason for your answer. Why is the squirrel changing direction? Well, this is the function. This is the graph of the function of a velocity. So if the velocity here is positive and then changes to negative, that's a change in direction right here. If it's negative and then turns to positive, well, that's a change in direction here. So you could say that the velocity or derivative, first derivative, changes sign at t equals 9 and 15. Okay, that would be worth a point. That would be a reason for your answer. So question A is out of 3 points. Go ahead and grade yourself now. Okay. All right. So let's move on to question B. All right. So question B, at what time in the interval 0 to 18 is the squirrel furthest from the building? How far from building A is the squirrel at this time? Well, what you're trying to find for B is distance. Once again, we need to make the connection that distance is a position. And the position is the integral of the velocity function. So we need to think about the integral of the velocity function. Well, we know that the integral of the velocity function is equivalent to, or the value, let's say hypothetically here from 0 to 9, from 0 to 9 of the velocity function is the area, the total area under the curve. Okay? Well, what's the total area under the curve? Well, that's a trapezoid. You could do 1/2 times base 1 plus base 2 times the height, or you could segment it into triangles and rectangles. It doesn't matter. You can find the area either way. But either way, when you do this, you get an area of 140 units squared. And let me just go ahead and work that out. So the distance or position from 0 to 9, I will notate this very tastefully using the integral, is 140 units squared. And I get that because of 1/2 base 1, which is 9 plus 5 times the height, which was in this case the height of this trapezoid. This is 9, this is 5, the height is 20. Okay, I hope y'all can see that. The height is 20. So there you go. And so it's 140 positive units squared. Well, what is this position? What is this distance traveled? Well, that's a negative area. Well, and no, there's no such thing as negative area, but as this is concerned, this is a negative value. Therefore, our squirrel is moving left, and moving left a certain amount, a certain distance, a certain position. So let's notate that by saying integral from 9 to 15 And you don't have to do this. This is all analysis. This is all figuring out the positions. So from 9 to 15, if we want to use our trapezoid formula again, that's integral of velocity. That's 1/2 base 1. We'll call that 8, and this is 4. Okay, and wait, 9. I goofed on this one. Alright, 7 to 15. 7 to 15. Yep, that is 8. And then 4, yeah, that is correct. For some reason I think we're a little bit off. 10 to 14. Yeah, that's 4. 8, 9. 14, 15. Oh, 9. No, that's 6. My bad. Okay. Whoopsie daisy. Miscounted. Okay. Alright, so good. So 1/2, that's base 6 plus 4, and the height here is 10. Okay, so the integral from 9 to 15 would be 10, 10, 150. 50 units squared. But in this case, this is a negative distance traveled. Okay, so if we were to just go ahead and move this up a little bit, okay, what is the last distance, or the last area here? Well, that's this one, which in this case, the integral from 15 to 18 is 1/2. 15 to 18, which is 3, and then that's 3, that's 2, and the height is 10. So that's going to end up being 25 units squared. Okay, so what we just did is we calculated the position from 0 to 9, the position, or the distance traveled from 9 to 15, and the distance traveled from 15 to 18. So at what point are we furthest from building A? Well, what is the value traveled from 0 to 9? 140 units squared in the positive direction. And then from 9 to 15, remember our velocity map? It's probably a long time ago, but that's what I was alluding to right here, this type of question. Alright, so 9 to 15, we go back 50 units. So where does that put us? That puts us at 90 units. Okay, but we're at a position of 90 units. We don't need this squared. Yes, this is area, but remember, the integral of velocity is the position. So not only are we finding units squared, we're finding the actual position in units. So here we're at 140 units. Alright, we go backwards 50 units, so we're 90 units, and then we go forwards to 25 units, so now we're at 115 units. So if you take all these and say, alright, what's the furthest one? Well, that would be 140 units. Okay, so we know the solution from 0 to 9 at time t equals 9, we are the furthest from the building. Because after we traveled 9 units of time, we are at 140 units. So this square. Can't see that. Okay, at t equals 9, the squirrel is 140 units from building A. This is the furthest time, or the furthest distance. Okay, let's break all this down and break it up into points. Okay, not too much wiggle room here. Basically, you get a point for indicating the correct time, and you get a point for 140, stating that the squirrel is 140 units from the building. And you may get a a point for for basically effort, showing that you know about integration and how you use the area under the curve to get the position. But I'm not quite sure. We'll count this out of 3 points. Okay? Alright. So next question, go ahead and grade this one. Alright, next question, here we go. Question C. Find the total distance a squirrel travels during the time interval 0 to 18. Well, we just did a whole bunch concerning distance traveled, so let's go back to that work. Okay, distance traveled. We said that after from 0 to 9, 140, from 9 to 15, 90, and from 15 to 18, we're now at 115 units. Alright, see that right here? So how much did we travel? The total distance traveled. Well, the total distance travel is not 115 units. Okay, because notice, total distance means it is not net distance. Total means there is no negative distance. So whatever distance we're traveling, we're considering positive. So after 140, we tack this on. This really becomes 190. And this is 190 plus 25, which is 215 units traveled. So for C, 215 units traveled. Sorry guys, this is only worth 1 point. Go ahead and grade your papers. Okay, out of 1 point. You can put the number correct out of 1 point. Sorry if I didn't clarify that, make that clear. Okay, last one, D. Write an expression for the squirrel's acceleration, velocity, and distance from the building A that are valid for the time interval 7 to 10. Now, when I talk about the time interval 7 to 10, guys, that's what I'm talking about. That's all I'm talking about. And that's all we need to think about. Okay, so you see this little line right here on the time axis from 7 to 10. Well, it's kind of glaring. That's all I want you to think about, guys. Pretend all this other stuff is gone. And think about, what is this equation? How can I find this equation? Well, it's a line. Does it have a point? Yes. Does it have a slope? Yes. Well, I can write the equation for this line in point-slope form. So let's do it. All right, let's write the 2 points down. That would be, in this case, D, 720 and 10, negative 10. Okay, x1, y1, x2, y2. Let's find our slope, which is negative 10 minus 20 over 10 minus 7, negative 30 over 3, which is negative 10. Can't see that, sorry. There's your slope. Okay. So now for our point, we're writing our point slope form here, which we should have memorized by heart. Okay, there. And we can plug any point we want in. We'll do this one. It doesn't have any negatives. So I'm using this point right here. And you could, it doesn't matter what point you use, guys. Minus 7, sorry. And then bam, bam, distribute. Negative 10x plus 70, y minus 20, y equals negative 10x plus 90. Alright guys, there's our function for, excuse me, let me pan out. There's our function for that line. Okay? So awesome, we got our function for that line. Well, what does that mean? Oh, we haven't answered the question yet. Oh, we got to figure out what this means. It is the equation for this line, which is part of the velocity function, the velocity graph. So this is really v of t. Okay? There's a point. You got your velocity function. What else do I need? My acceleration function. Well, how do I get the acceleration function given the velocity function, guys? Come on, quick. Oh, we take the derivative, right? The derivative of the velocity function, bam, bam, that's a constant, it becomes 0, so the acceleration function is -10. That's it. Give yourself a point. Third point, the position function. How do I get the position function given the velocity function? Think. I have to integrate the velocity function, which gives me the integral of -10x plus 90, which is -5x squared plus 90x plus c. Alright, that's my velocity, or not my velocity function, that's my position function. -5x squared plus 90. And forgive me, that should have been t, but I don't, just pretend that's t, I'm sorry. -5x squared plus 90 plus c. So, how do I find c? Oh my goodness, we gotta find an initial condition. Where is it? Boom! Right there. A squirrel starts at building A at time t equals 0. It starts at the building. What's the distance from the building? If it's at the building? 0. So at time t equals 0, the distance is 0. So the distance is 0 when I plug in 0 for the time. Boom. Sorry. C equals 0. Therefore, your position function, x of t, is equal to -5x squared plus 90x plus 0, or not. Give yourself a point. Alright, big question, a lot of stuff, a lot of things going on. It's only worth 3 points though, so count yourself out of 3. Alright guys, appreciate you paying attention, and let's move on and get better.